Force of gravitation. Variation of weight. Good morning. We all feel weight in our daily life, but would you know the weight of the same object varies at different places?
No.
I will tell you an interesting story. 125 kg of gold was taken from Thiruvananthapuram to London, was weighed there using a spring balance. It was found that there is an excess weight of 0.5 kg approximately.
Sir, is it not the same weight for a body at Trivandrum and London?
The suspicious officers weighed it again using a common balance and found no difference.
Sir, why this is happening?
What is then weight? How it varies from place to place in the earth?
Here we are discussing how this happens. Consider a body of mass small m on Earth of mass capital M. R is the radius of Earth. Then force exerted by Earth on a body placed on its surface, F equals capital G into capital M into small m divided by R squared equals small m into capital G into capital M divided by R squared equals small m into g, where small g equals capital G into capital M divided by R squared. F equals small m into small g. This is the weight of the body at that place. This force is due to the gravitational force between the earth and the body. The weight of a body of mass 1 kg would be 1 into g Newton. This is called 1 kg weight. So weight is the result of gravitational force. When we hold an object, we feel a downward force on our hand due to its weight, which is equal to the force with which it is accelerated by the earth.
Will the weight be more from the surface of Earth?
The gravitational force of the earth on an object decreases as its distance from surface of the earth increases. Let us look into an example. Suppose a body of mass 1 kg is raised to a height of 6,400 kilometers, that is radius of the earth. Then the gravitational force gets reduced to 1/4. That is, the weight reduced from 9.8 Newton to 2.45 Newton. Here the mass is the same. Now let us try to raise the body a distance d from the earth's surface. Now r becomes r plus d. So small g reduces. Thus F reduces. That is, the weight of the body decreases when it is moved away from the earth's surface. In short, the weight of a body is maximum when it is on earth's surface. It decreases when the body is moved out. Let us check another situation. What will happen if the body is carried to the interior, to the earth? Here the weight of the body does not increase, but decreases. Why this happens? As we know, a body on the surface of the earth is attracted by the earth in one direction, that is, towards its center. But when the body is within the earth, the forces of attraction from different sides. That is why the weight of the body decreases when it is moved in. at the center of the earth, the body will have no weight at all.
Then, where will the weight be more from the center of earth?
This is because the force of attraction from different sides of the earth, which are equal in strength, cancel each other. In short, the weight of a body is the maximum when it is on Earth's surface. It decreases when the body is moved out or in. What do you know about the shape of the earth?
It is not a perfect sphere.
That is, the distance from the center of earth to the poles and that to the equatorial region are not equal, isn't it?
Very good. That is, the gravitational force on the body is maximum at the polar region and it is minimum at the equator. Now looking this equation, F equals small m into small g, where small g equals capital G into capital M divided by r squared. The value of small g changes in relation to the change in the value of r. That is, at the equatorial region, r increases and the weight decreases. At the polar region, r decreases and the weight increases. Did you understand now why the variation of weight at Trivandrum and London? The value of capital R is more at London, so it is weighed more in the spring balance. That is, when an object is suspended from the hook of a spring balance, the object undergoes a gravitational pull and the spring extends depending upon that pull. It is this force that is measured in the spring balance. This is the weight of the object. When taken to different parts of the earth, this force will be different. Therefore, the weight of the object also will be different.
But it was not varied when weighed in common balance?
Yes. In the common balance, the mass placed in each pan is compared with that of the other. Since one of the pans holds a known mass, the mass of the object placed in the other pan can be found out. When taken to different parts of the earth, the change in the gravitational pull is felt equally on the objects in both the pans. That is why the weight of gold was not different when weighed with a common balance.
Is it the same weight for a body at Earth and Moon?
The weight of a body on the Moon will be less than its weight on the Earth. As we know, F equals small m into small g, where small g equals capital G into capital M divided by r squared. This is so because the mass of the Moon is 1 by 81 of the mass of the Earth, and its radius is 1 by 3.66 of the radius of the Earth. Therefore, the acceleration due to gravity small g experienced on the Moon will be less than the acceleration due to gravity experienced on the Earth. This will be about 1 by 6 of small g.